Hello, I'm George, and in this video I will present you my thesis work that I completed during my master degree in data science. So the title of this work is Adversarial Machine Learning to Enhance Bot Detection. Okay, at this point you must be wondering what is adversarial machine learning and what is bot detection. I'm going to explain it to you in simple words, starting with bot detection. You all know social media. In fact, a day doesn't go by without accessing your smartphone to check for new posts or messages on Facebook, Instagram, Twitter. Over the last years, social media platforms have experienced an enormous amount of new users. In 2017, there were roughly 2.7 billion social media users. Nowadays, social media platforms accommodate 4.6 billion users, and this number is expected to reach almost 6 billion users by the end of 2017. Okay, so far so good. But have you ever wondered if the content you read on social media or the accounts that you follow are authentic and refer to real humans? With the high growth of social media, the amount of fake content and fake accounts has greatly increased. The responsibles behind this fake content are automated accounts, also known as bots, that tend to mimic human behavior by posting content and interacting with humans in order to achieve their goals. Especially on Twitter, bots find a great opportunity to spread misinformation and fake news, negatively affecting people's thoughts. In fact, a recent study showed that 35% of the content posted on Twitter is generated by bots. You can now realize the impact that these malicious accounts have on our lives, and that we need to take measures to detect those accounts and effectively suspend them. So far, we have talked about social media, bots, and the need for their detection. However, we haven't talked about how this bot detection happens. And here is where machine learning comes into play. Machine learning is an application of artificial intelligence that enables systems to learn and improve from experience without being explicitly programmed. Machine learning focuses on developing computer programs that can access data and use it to learn for themselves. In the case of bot detection, a machine learning model is built to distinguish bots from legitimate human accounts, given some data that describes social accounts, for example Twitter accounts. However, current machine learning approaches for detecting bots present a weakness. This weakness concerns the inability of these models to keep up with the evolution of bots. But what is bot evolution, you may ask? Bot evolution is the phenomenon where bots are evolving by becoming more sophisticated and more similar to humans. Therefore, it becomes quite hard to detect them. In addition, as bots evolve, new types of bots emerge. For this reason, it is necessary to develop a detection technique that is able to identify future generations and types of bots before they even emerge. And that's what we have accomplished with the help of adversarial machine learning and generative adversarial networks. But what are generative adversarial networks, or GANs, let's say for short? GANs are a specific type of machine learning algorithms and are composed of two models, the generator and the discriminator. The generator creates synthetic data that looks like the real data, while the discriminator tries to distinguish synthetic data from the real ones. In this context, a GAN learns to produce artificial data that looks like the original data. In our case, we trained a GAN using data from Twitter accounts, and we managed to make the GAN create artificial bots that are similar to the existing ones, simulating evolving bots in this way. Next, we used the artificial bots we just created to augment the existing bot data, constructing a bot detection approach that is proactive and efficient against future generations of bots before they even emerge. To evaluate our methodology, we considered one old dataset for training and three newer datasets for evaluation. The idea is that the old dataset contains outdated bots, while the more recent datasets contain newer bots. The results show that when we apply our proactive technique, we are able to improve the detection accuracy of new bots by up to 10%. This confirms that our proposed method can effectively simulate bot evolution and help detect new bots. To sum up, in this video, we've talked about bots, how we detect them, and a proactive approach that we developed in order to keep up with bot evolution. If you're interested in learning more details about this work, please don't hesitate to contact me on my social media or email. Thank you for your attention and see you in a future video. Bye!